Here's an explanation for the answer to final exam question number 72 in Electronics Demystified, 2nd edition. If you have the printed book, please refer to pages 432 and 433. We're talking about what we should do if we have a direct conversion receiver and we want to receive a frequency shift keyed signal, otherwise known as FSK. FSK, as you remember, is a signal that has a mark at one frequency and a space at a slightly different frequency. Remember, with a direct conversion receiver, what we get is a beat frequency between the actual signal carrier, which in this case are shown by these two double vertical lines, and the local oscillator frequency. What I have done here is drawn an example of a frequency shift keyed signal with an offset of 170 Hertz. That means that the mark and space frequencies differ by 170 Hertz. That is a typical shift or offset value for ham radio frequency shift keyed communications. So here's a signal here, and here's a signal down here. These frequencies are standardized to produce audio frequencies in ham radio receivers, and the standard frequencies that I have seen used are 2125 Hertz for the mark and 2295 Hertz for the space. Those are the audio frequencies. Notice they differ by 170 Hertz. Sometimes signals are sent upside down, in which case the 2295 Hertz audio frequency would represent the mark and 2125 would represent the space. It really doesn't matter as long as they are clearly differentiated and 170 Hertz apart. So what we want to do is we want to tune the local oscillator a few hundred, or in this case quite a few hundred Hertz above or below the signal frequency. So the local oscillator and the signals differ by the requisite audio beat frequencies. The only answer that will provide that state of affairs in this situation is choice A, a few hundred Hertz above or below both the mark and the space frequencies. That's this local oscillator frequency right here. So if we set this local oscillator frequency quite a few hundred Hertz below both the mark and the space frequencies, then we have this state of affairs shown by the pair of red vertical lines for the signal. If we set the local oscillator frequency above the frequency shift keyed signal by the requisite quite a few hundred Hertz, we will get this state of affairs. So either one will work with a direct conversion receiver, because the direct conversion receiver does not differentiate between one sideband and the other. So again, the correct answer to this question is choice A.